Hello everyone. Welcome to this session. Here we will be discussing about some of the most significant built-in methods of Pandas. These methods in Pandas helps us in data pre-processing, cleaning, as well as in data analysis. Let's discuss them in detail. We know that Pandas supports two types of data structures. We have already discussed them in detail in the Pandas tutorial video. So the two common data structures supported by Pandas are series and data frames. Series is basically a one-dimensional array which has the data and it's labeled by an index. On the other hand, pandas are two-dimensional data structure which is just like an SQL table, CSV, or an Excel file. It contains rows and columns. So most of the built-in methods are applied on these data structures. We will look them into details. So the first method is the ndim method. So this method tells us about the dimension of the data structures. We can see this in the example that we have created a series and the output of the n dimension on series is 1 because series is a one-dimensional data structure. In the second example, we have used the ndim method on the pandas data frame and the output is 2. The output is 2 because we know that pandas data frame is a two-dimensional data structure. Access method returns the list of the access of rows and column access labels. So in the first example, we can see that we have applied this method to a series. We already know that series is one dimension. So the output here only shows a single value representing a single row. In the second example, the access method is applied on a data frame. The output has three parts. The first part represents the row and its range of values, and the second part represents the columns, and the third part has the data type. The values method returns the actual value present in the data structure. For example, we have the following in the first example. We have created a series with the numbers from 1 to 100, and the values method, when applied, displays them. In the second example, the values method is applied on a data frame, which displays the value present for each and row and column respectively. Head method in pandas returns the first n rows of the data structure. It has only one parameter, and this parameter determines how many values we want to see. In the example, we can see the value is 6 in the head method. So the six first values of the data frame will be displayed. By default, the value is 5. So if we don't specify any number inside the head method, the first 5 number will be displayed. First 5 rows will be displayed accordingly. In a similar way, tail method returns the last n rows of the data structure. It has only one parameter, and this parameter determines how many values we want to see. In the example, the value is 3 in the tail method. So 3 last values of the data frame is displayed. And by default, the value is 5. Sum method returns the addition of values for the axis. We can see that we have created a data frame which contains two columns, even and odd, containing even and odd numbers ranging from 0 to 80. When we apply the sum method, it will calculate the sum of each columns and will display the results. Standard deviation method is just similar like sum, but instead of calculating the sum here, we are calculating the standard deviation of the particular column. So it returns the standard deviation of values for the axis. We can see that we have created a data frame which contains two columns, even and odd, containing even and odd numbers ranging from 0 to 80. When we apply standard deviation method, it will calculate the standard deviation of each columns and will display the result. Next method is the iteritems method. So basically, the item methods iterates to each column as a key value pair. Here, the key value is the column name and the series object of the column values as value. In this example, we can see that we have created a data frame of random values with 5 rows and 4 columns. When we apply the items on this data frame, we can see that the output displays columns, its values, and the data type respectively. Iterrows method iterates through each row as key value pair. Here the key value is the row name and the series object of the row values as value. In this example, we have created a data frame of random values with 5 rows and 4 columns. When we applied the iterrows method on the data frame, we can see the output displays row and its corresponding column values and the data type respectively. The other method is the itertuple methods, which returns an iterator yielding a named tuple for each row. In this example, we can see that output returns tuples where each tuple is representing a row, and each tuple object contains the index of the row and the column values. One of the most important methods of pandas is the group by method. With the help of this method, we can group the rows based on the values of a column or multiple columns. Then we can apply the different aggregation or transformation method accordingly. In this example, we have created the data frame champions. Then we have grouped the data based on the column named team. As we know, we can apply various aggregation or transformation methods on the group data. In this example, we are doing exactly the same. We are using the same data frame which we have created in the previous slide. We have grouped the data on column named team. Then we have used the get group method to get the details of RCB team. So the output contains the details of the RCB team. Now, the next thing is about the aggregate function. So we know we have already seen about the group by method. So once the group by method is being performed, we can apply the aggregation function. So basically, the aggregation function is mostly used on the group data. In this example, we can see that the data frame is grouped by the column gender, and then we have used the aggregate function to get the mean and sum of the salary column. So the output will display the mean and sum of the both male and female respectively. Concatenation is also one of the most important built-in methods supported by pandas. So basically in concatenation, it is the process of combining two or more data structure into a single data structure. In this example, we can see that I have created two data frames called champions underscore df and chokers underscore df. Then we have called the concat method and passed the two data frames as parameter. So as a result, both the data frames will be added vertically. We can see the resulting data frame containing all the data from the data frame. Concatenation can also be done horizontally. For doing this, we need to specify the parameter axis with its value as 1. We can see the output has been added two data frames horizontally. By default, the axis parameter value is 0, which means that the concatenation will be done vertically by default. Merging in pandas helps us in joining two data frames with the help of a common value. In the above example, we have two data frames, champions underscore df and match stats df. We will call the merge method and specify both the data frames as the parameters. There is also one of the parameter which is called as on. The on parameter shows that whether we have to where we have to specify the common column for both the data frames on which the merging should happen. So in the example, let me go back. In the example below, we can see that we have used the in the on parameter we have used the column team. So in the team, where team is the column on which the merging will happen. Left join is a type of merging where the resulting data frames contains all the elements from the left data frame and the matching rows from the right data frame. In the example, we can see that the left data frame is champions df and right is chokers. We have used a parameter called how, where the value is left. So as a result, the output data frame contains all the elements from the champion underscore df and the common elements from the choker underscore df. Right join is also a type of merging where the resulting data frame contains all the elements from the right data frame and matching rows from the left data frame. In the example, we can see that the left data frame is champions underscore df and the right is chokers underscore df. We have used a parameter called as how, where the value is where the value is kept as left. So as a result, the output data frame contains all the elements from the chokers underscore df and the common elements from the champions underscore df. Outer join is a type of merging where both the data frames are included, including all the elements of both the data frames. So we have used the parameter called how, where the value is outer. So we can see that the resulting data frame contains all elements of both the data frame. Here, NaN represents the missing values in the data frame. Inner join is a type of join operation where the resulting data frame contains the common elements of both the data frames. We have to keep the value of how parameters as inner. In this example, the resulting data frame is empty because there are no common elements between champion underscore df and chokers underscore df data frames. So this was all about the built-in methods supported by pandas.